Okay, we are going to start with review of ratios. These book pages might look a little bit different. They're actually from the math books from last year. We just really like the review they had and also some more of the problems and then also how they model the problems. So we're going to use these pages. You should have been given a copy in class. If you for some reason forgot them at home, forgot them at school and you don't have them at home, there will be a PDF version in Google Classroom, or just have a notebook piece of paper out beside you so you can work out the problems along with us as we go through. So we're on the first two pages of the packet. We're looking at ratios, just another way to look at them. So we've dealt with fractions in 5th grade and in 6th grade, and you know that a fraction is a way to compare a part to whole relationship. Okay, so those key words of part to whole is what we're going to focus on a lot today. Okay, we're taking one part and comparing it to the whole class or the whole amount. So think of it in class as if we compare the girls to the total number of students, or the boys to the total number of students, or wins to the total number of games played. We're looking at that second. That's our whole, what we start with. A part is if we're looking at one section of it. So we're given two different situations here that we're going to work through. We're going to be looking at tennis balls and baseballs. Okay, so two different types here. Carlos has 4 tennis balls and 5 baseballs. So you can see there are 9 total here. So before we even get to the problem, we can talk about this just as a real life situation. So if we have 4 tennis balls and 5 baseballs, we can actually talk about the ratios here. We can talk about part to part. Okay, and we can also talk about that part to whole piece. Okay, so if we have 4 tennis balls, we can compare that to baseballs as a 4 to 5 ratio. For every 4 tennis balls, there are 5 baseballs. We could also take this as a part to whole. For every 4 tennis balls, there are 9 total. Or for every 5 baseballs, there are 9 total balls in the set. Okay, so those ratios, doing that before we even get started, can actually help us solve the problem. So looking at the first one, use the math you already know to help us solve. Well, we kind of already set that up over on the right-hand side here. So what fraction of the balls are tennis balls? So we're going to write ratios as a fraction. So this is a colon. We've talked about using the word TO, but we could also write that as a fraction. That bar can mean 2. So 4 to 9. For every 4, there are 9 total. So what fraction are tennis balls? So we can look. We have 1, 2, 3, 4. So if I'm going to write this as a fraction, 4 over 9. What fraction are baseballs? 1, 2, 3, 4, 5. It tells us that. Our fraction is 5 to 9. You can also compare two quantities with words. You can write the numerical comparison, numerical being number comparison, of 4 tennis balls to 9 total balls as simply 4 to 9, 4 to 9. Write a comparison of the number of baseballs to the number of total using the word to. So, order matters. So they're asking us to put baseballs first, then total. So we're talking about how many baseballs we have. We have 4. There are a total of 9. So our ratio is 4 to 9. You could also put 4 baseballs to 9 total balls, whatever you want to put there. Okay. You can also use a colon to separate quantities when you compare numbers. Use this notation to compare the number of each type of ball to the total. So the colon's the 2 dots. So we could write this as 4 colon 9. We can also compare baseballs as 5 to 9 that way. Okay, so 2 different ways to write the TO or the colon. We also use the fraction bar. So actually 3 total. How does each of these notations, the fraction, the TO2, and the colon, compare the number of tennis balls to the total number of balls? So what that question is looking at, what are we actually doing here? Like, why are we doing this? Okay, so that symbol, the fraction bar, the word to, and the colon, is a separation symbol. Okay, so it separates the 2 values. Okay, writing the numbers 4 and 9 beside each other are obviously going to look like 49, which doesn't make a whole lot of sense. So there's separation, they're that comparison. So 4 to 9, 4 over 9, that fraction bar, the colon separates them. So go ahead and go to your next page here. Sometimes you can compare the two parts. So if we're looking here, 4 tennis balls to 5 baseballs, you can also flip it and say 5 baseballs to 4 tennis balls. This is when order matters. And I know you've heard us say that before. You're going to hear it plenty of times. In a ratio, if they say baseballs first, then tennis balls, you have to write the baseballs first. Okay, so make sure whatever words are in the statement, that's the word you're using. So to write, so that's the two parts, the part to part. To write a part to whole, this is the 4 to 9 and the 5 to 9. That 9 is your total. Okay, so when you're thinking of part to whole, think of the word total. Okay, and the part to part are both pieces. To write a ratio, you can use the word TO, a colon, or a fraction bar. The expressions 4 to 5, 4:5, and 4/5 all represent the ratio of 4 compared to 5. There are many ways to compare the number of balls. So we've talked about part to whole to part. Okay, 3 separate ways. And you can look through there and read it on your own. If you want to pause and read, that might be best for you, so I don't overwhelm you. But look through those different ways that you can compare. In class, we've used the next two phrases a lot. You can also use the phrases for each and for every to describe ratios. For example, 4 tennis balls for every 5 baseballs. 4 tennis balls for each set of 5 baseballs. So the words for every and each. Okay. So the reflect question, I'm going to read it and then I want you to try it on your own. Pause and try it and then check your work. Suppose Carlos was given a basketball. What is the ratio of tennis balls to baseballs? What is the ratio of total balls to tennis balls? Compare the ratios before Carlos got the basketball and after he got it. How did the basketball affect the ratios? So take a second, hit pause, try to solve, and then come back and check your work. Okay? So if you've tried this, let's go ahead and look at it. I always start by writing down what I know. Okay, I know that I have 4 tennis balls. It came back to the original problem here. I know that I have 5 baseballs, and now I know I have 1 basketball. And I'm going to go ahead and put the word total down here, just in case I need that. 4 plus 5 is 9, 9 plus 1 is 10. Those are my 4 values that I'm going to use. Okay, so here's what we have. This is what Carlos has. What is the ratio of tennis balls to baseballs? So I'm going to come over here and I'm going to look. There's tennis, there's baseballs. Order matters. Tennis balls is first, baseballs is second, so my ratio has to go in that order. So I have 4 tennis balls to 5 baseballs. That ratio is not changed from the top. Okay, but remember, order matters. Tennis balls is first, baseballs is second. What is the ratio of the total to tennis? Now I can come over here and look. Well, there's my total. There's my tennis. Order matters. Total is first. Tennis is second. My total is 10. Tennis is 4. So my ratio is 10 to 4. Compare the ratios before Carlos got the basketball and after he got it. How did the basketball affect the ratio? Okay, did it affect the part to part? Because this 4 to 5 is my part to part. That didn't change. What did change, the only ratio that changed was when we did part to whole. Okay, because what changed was the whole. Okay, or whole to part in this case, because they did the whole first, which was the total. Okay, so when we add a new amount, if you're comparing it, that total now is 10 instead of up here, it was always 9. Okay, so reread through here. Focus on this. Really focus on that part to part to whole, and whole to part.